Welcome back to another lesson in Math 8. Today we are doing Unit 4, Lesson 8, How Many Solutions? We are going to look for strategies to be able to figure out how many different solutions there are to an equation. If we take some time and actually watch what we're doing and look at it step by step, we can start to recognize what it means to have one solution, no solution, and infinitely many solutions. Just a quick recap. One solution means that there is only one answer, one number possible that can actually answer the equation and make it true. Infinitely many solutions, or all solutions, means that it can be any number you want. All of the numbers that can absolutely be imagined will make the equation true and will work as a solution. And then no solution simply means there is absolutely no way that you can actually get a solution for the equation. So what we're going to look at is we have an unfinished equation here, and we're going to look at the three solutions or the three expressions that are given here in parts A, B, and C. We need to match the following expressions with the number of solutions the equation would have if the expression right here was matched up with the other expression that's given. In order to do that, the very first thing that we always want to do to decide if the numbers or what the number of solutions are is we always want to simplify. And so I'm going to take this expression right here. I'm going to go ahead and simplify it right here. So we have 12 times the difference of x and 3, and then we add 18 to it. If I go ahead and use distributive property, this will be 12 times x, and then 12 times 3. So this would be minus 36, and then we would add 18. And then we would simplify that negative 36 or the minus 36. If I just simply cover up the 12 times x, I see that that is a minus 36. And so when we talk about a negative 36 and a positive 18, we are actually going to make that a much smaller number. We'll have 12 times x minus, here's my quick strategy. I take away 8 from 36. So by taking away 6 first, we're going to get that down to negative 30. Adding 8 to it. Adding 8 is going to make that negative 28. And then adding 10 more is going to make that a negative 18. So minus 18 equals. Now that I have that simplified, I want to look at the structures of each of these ones and simplify them as well. 6 times 2x is 12 times x, and 6 times a minus 3 is a minus 18. 4 times 3 is 12, making this a 12x, and 4 times minus 3 is a minus 12. And then the final one, 4 times 2 times x, this would be 8x, and 4 times minus 3 is a minus 12. Now, given these structures, what I'm going to look for is I'm going to compare these expressions across to each other. The very first expression, I know this is 12 times x minus 18, and when I compare that to the other one, when I look here, a is going to be 12 times x minus 18, as we see right here, is equal to 12 times x minus 18. The very first thing I notice is that the expressions are exactly the same. That means even if I added 18 to both sides, that would eliminate the 18, leaving me just 12 times a number. And I know that 12 times the exact same number will always come out the same. I know that this first one goes to all solutions. So A and 3 match up. I know this is all solutions because no matter what number I substitute for x, I will always get the exact same product, and then I'm always going to take away the exact same amount. So that will always be the same. Looking at letter B, we have 12 times x minus 18 compared to 12 times x minus 12. The way that I like to look at no solution situations, this one is a no solution, is I like to take that 12 times x, and if I cover that up and I cover that up, I'm left with a negative 18 compared to a negative 12. And I look at that statement. The reason I can eliminate that is because if I subtract 12x from both sides, that eliminates that value, and what I'm left with is negative 18 equals negative 12. That is absolutely a false statement. That will never, ever be a true statement. And so I know right away that there is no solution that can make this true, because the expression over here, after finding the exact same product, let's say if x is 2, then that would be 24 minus 18 compared to 24 minus 12. And that simply can never, ever come out to the same value. So I know B is going to match up with no solution. C is kind of a no-brainer at this point, but I want to show you the essence of this. 12 times x minus 18 is equal to 8 times x minus 12. What I see right here that's different than the previous two is that the coefficient of x is different in each expression. With that understanding of being different in each expression, the previous expressions, when we had 12 times x here, and if we went ahead and subtracted that 12 times x, that eliminates both of those expressions to where we're just comparing, or both of those terms to where we're just comparing the constants. We know this is always false. Whereas up above, we saw 12 times x minus 18 is equal to 12 times x minus 18, or when I do the exact same thing, I see nothing but truth in negative 18 is equal to negative 18. This one is true, this one is false. But here's what I want to look at with that when I look at the third one, C. When I see 12 times x, let's just separate that, minus 18 is equal to 8 times x minus 12. When I go to eliminate the variable from one side, I don't eliminate it from both sides. I'm still left with a variable that I have the option, or that I have the ability to find its value. The key thing when I'm looking for one solution is recognizing that I have different coefficient values on both expressions. So just a quick recap. All solutions, my expressions are exactly the same. Coefficient and constant match up with the coefficient constant on the other side. No solutions, coefficients of x or of the variable are always equal, constants are not. And letter C, coefficients are not equal. So one solution do not have the same coefficients. Let's go ahead and put this to practice. We're going to skip over 8.2. And here in 8.3, the concept is this: for each equation, determine whether the situation has no solution, exactly one solution, or is true for all values, meaning infinitely many solutions. If the equation has one solution, then we have to solve that equation to make the statement true. Looking at these values, what we talked about just a moment ago was we want to look at the coefficients of x. And we see right here that I have 6 times x on the left side and 7 times x on the right side. Within one quick step, I find out that I did not eliminate my variable term, which means I still have the ability to find that variable term. And the quick option is to recognize I have different coefficient values for that x. And so I'm going to go ahead and finish solving this right over here. 8 is equal to x plus 13. Subtraction property of equality tells me that I need to go ahead or that I can eliminate that 13. 8 minus 13 is a minus 5 for x. I want to verify that I'm right with this. 6 times a minus 5 plus 8 compared to 7 times negative 5 plus 13. That makes this negative 30 plus 8 makes that a negative 22. And then a negative 35 plus 13. Negative 35 plus 10 is negative 25, plus 3 more is also negative 22. I know that I'm right. Therefore, x equals negative 5. Okay, on the next one, we'll go ahead and simplify using distributive property. 2 times 3x is 6x plus 8. And when I compare the two together, I see that I have the same coefficient for x, the same constant value, which means no matter what I plug in for x, this product will always be increased by 8, making this all solutions, or what we call infinitely many solutions. If I wanted to, I could go ahead and break all this down, subtract x or 8 from this side, 8 from this side, divide by 6, and I just simply get x equals x. So all values for x will always be equal to each other. The final one, when I look at this piece, if I wanted to think in the reverse, I want to eliminate the coefficients or eliminate the variable, or I want to put the variables on the same side. When I subtract 6x from the left, I also subtract 6x from the right, but the problem is they're eliminated, and I'm left with 8 equals 13. This is a false statement telling me that there are no solutions here. All right. The next one, we'll go ahead and simplify. 1/4 of 12 is 3. 1/4 of 4 times x is going to be a 1x, which gives me 3 minus x on the right. Now this one, don't be fooled by this. Just because there's a 1 there doesn't mean there can't be a 1 here. And I see the expressions are exactly the same. This again, all solutions. If I were to eliminate the 3, divide by -1, I just get x is equal to x. Or if I add 1x here and add 1x here, I see 3 is equal to 3, which is always going to be true. Letter B, what I want to look at here is I see x minus 3 and 3 minus x. Don't be fooled by the looks of it. These are not the same expressions. What I want to do is I want to go ahead and start by paying attention to the variable terms. I'm going to go ahead and add x here and add x here. And what might surprise you is this one actually turns out to 2 times x minus 3 is equal to 3. These two x terms are different. This one shows us a positive x. This one shows removing a positive x or negative x. These are different coefficients. This one you can think of as a coefficient of -1. This one as a coefficient of +1. By understanding that these two coefficients of x are different, we see that there's one solution, and that one solution, as we simplified on both sides, turned into, or as we did our first step of addition property of equality, turned into twice the value of x minus 3 is equal to 3. We'll go ahead and finish this with the addition property of equality, followed by the division property of equality to get x equals 3. I want to verify that I'm right here by substituting 3 for x. 3 minus 3 compared to 3 minus 3. Pretty simple check on this one. 0 is equal to 0. I know that x is equal to 3. I know it for a fact because when x is 3, I get a true solution here. Finally, on the very end, I see that x on the left, x on the right, these two values are equal to each other, positive x, but then I look at their coefficient or the constant value, and if I can eliminate that x, subtracting x from this side, subtracting x from this side, gone, gone, this makes a false statement. This is no solution. Okay. The final one, I want to leave that one to you, but I don't want to leave you completely hanging. I'm going to simplify a few things. -5 times x minus 3 times x plus 2. I know a -5 times x minus a 3 times x is a -8 times x plus 2 is equal to -x, 8 times x plus 2. The next one, -5 times x minus 3 times x is a -8x minus 4 is equal to a -8x plus 2. And then finally, a -5x minus 4 times x is a -9x minus 2 is equal to a -8x plus 2. Take a look at your coefficients of x. I see in the first one, same. Second one, same. Third one, different. Well, different automatically tells me one solution. I go back to these two, so now I have to figure out which one is infinite and which one is none. So our next step would be to look at the constant value, and seeing that our constant value is exactly the same in 3a means that once I find this product and I add 2, I get the exact same values. So all solutions. This one right here, once I multiply that by this product, I will look and see that the product -4 versus the product +2, the same thing is not happening here. These ones can never be equal. This is no solution. Your job now is to solve this last one and make sure that you get the correct value for x. There are 2 more here. Again, simplify, simplify, simplify. Compare the coefficients, compare the constants. Remember that same coefficients means that you have all solutions or no solutions. Different coefficients mean that you have one solution. So what do you notice about the equations with one solution? Let's talk about that. One solution equations have different coefficients, right? The variable term is not eliminated. Okay, that's the big thing. How is this different from the equations with no solution and equations that have true values? The other ones, infinite and none. When we look at these two, the variable term is eliminated. Meaning that when I apply the addition property or the subtraction property, it's simply gone. It's eliminated. And we're left to just comparing the coefficient or the constant values that are left, not the coefficients. So pay attention to those things. Give them your best shot. I do want to go through the summary with you. It says sometimes it's possible to look at the structure of an equation and tell if it has infinitely many solutions or no solutions. For example, when we look at this equation, we use the distributive property on the left and right sides, and we simplify it to 24 times x plus 36 plus 6 is equal to 18 times x plus 6 times x plus 42. We go and we collect our like terms together, meaning I'm collecting the terms that do not have variables together, or I'm collecting the terms that have the exact same variables together, not mixing the two together. That's like saying all red Skittles are sour, and they're not. You have regular red Skittles and then you have sour Skittles, and these are not the same. Neither are those, even though they're delicious. Since the left side, when we simplify after collecting the right terms, 24 times x plus 42 is equal to 24 times x plus 42. Since the left and the right sides of the equation are the same, we know that this equation is true for any value of x without doing any more moves. We see the exact same coefficient and the exact same constant. If I were to eliminate the coefficient, I get a true solution. 42 is equal to 42. If I eliminated the eliminated the 42 from both expressions, I get 24 times x on both expressions, which we know that the product of 24 and x is always going to be equal to the same. I get the exact same thing no matter where I go. When we look at the structures for something that has no solutions, we do the same thing. We simplify both expressions, and then we look at them a little bit more. In this case, we did something a little bit different. We can think about it as we take each move. Seeing that we have 6 out here, 6 right here, or 12 right here, and 12 right here, there is a common factor of 6 for each of these terms. So if I multiply by 1/6, it does make things a little bit simpler. Likewise, you could, if you wanted to, go ahead and distribute, and you get 36 times x plus 30 is equal to 36 times x plus 24 plus 12, which gives us 36 times x plus 30 is equal to 36 times x plus 36. And then that last move makes it very clear. The constant terms on each side, in this case, they had a 5, and over here, the very last thing we would see is 6 times x plus 5. Whoops, sorry, struggling to write today. And 6 times x plus 6. We see it's very clear that 5 and 6, those two constant terms, are not equal to each other, which means that we will never ever get the exact same value on both sides of the equation. Likewise, up here, 36 and 30, different constant values. So pay attention to those moves. Pay attention as you go through the moves. You should be able to identify how many solutions just within a couple of steps. Let me know if you have any questions. Pay attention to your vocabulary. Know what constant terms are. I would also add to this one coefficient. Oops, sorry, you want to see that? And this is what we call the number part of the term, such as 4 times x. The 4 is the coefficient. And then the constant terms is just, it's a number where it does not have a variable that's attached to it. That's it for now. See you in the homework.